All right, guys. I'm not sure how to parse that statement. We could be in chapter 8. Would you love me then? I mean, I could just slam
that
all
would mean that we'd be done with class damn near, so yeah.
Does everyone want to do that in the first 10 minutes? I can just speed lecture.
No, I'm going to go fast enough as it is.
All right. So I can deal with a few people hate me. That's fine.
No, you don't hate us. You hate us.
Oh, that's silly. You guys have done this before, I'm pretty sure, but let me make sure you understand how this works and why it works the way it does. Let's overanalyze this, which is big for me because I don't like to analyze. But x greater equal to 7. Exactly how and why do you graph it the way you do? And the reason we're going to overanalyze this is because then I can talk more directly about how to do it when there's 2 variables in there instead of just 1. Oh, joy. So what's the most important point to plot on that graph if you're going to graph this solution? 7. Because that's the dividing line between good and evil. No, between answer and not answer. Right? Let me make sure you understand what I'm saying. How many dimensions is this? 1. 1 variable, 1 dimension. I can only move left or right here. Right? The dividing point of a line is a point. And that point divides it into answers and non-answers. On one side, there's all answers. On the other side, there's no answers. So, of course, we know which way to go. But real quick, one way to do this is just to plug in a number and see if it works. Does 8 work? Is 8 bigger than or equal to 7? Yes. Does 6 work? No. So this must be the answers. And, of course, we put a little bracket on it because we want to include it, right? What used to be a closed circle there. How are we doing? So, of course, we all know how to do that. I just overanalyzed the hell out of it because now I'm going to try to make more sense out of this. Let's see. Y greater than or equal to x plus 7. So now I've got 2 dimensions because I've got 2 variables. I have 2 axes, right? What's the dividing thing for a plane? If I have a plane, how do I cut it in half? So if I have this piece of paper, which I do, how do I cut it in half? Throw it up and have a sound like, right? So it would go, you know, a line. Some kind of line would cut it. Doesn't have to be in half, but just to, you're with me? So if I have a line, I use a point. A point would cut it in half. If I have a plane, a line cuts it. This is easy. What's the point? 7. Okay, and one side works, one side doesn't. What's the line here? X plus 7. Because I've solved it for y already, right? So the first step on these problems is graph the line and then figure out which side of the line to shade. Because what this is saying is there's a lot of points that make this work. If it was y equals x plus 7, the only points that make this work are the points that are on this line. Right? When I graph a line, I'm going right through all the points that work. The inequality allows for more answers, right? You don't have to be on the line. You can be above the line somehow. Y greater than that line. Cool? And these kind of inequality problems here are good for restrictions on things. So in an elevator, you would say you can only have this many pounds on the elevator before it's going to plummet and everyone's going to die. So you say that plus that must be less than or equal to this. And then you can graph it and say, here's my safety zone, right? If I have a point outside of that, it's not good. Episode of Mythbusters is in the future. So what do I know about this line? So number one is you got to be able to graph a line. So what do I know about the line that's going to help me graph it?
On the y-axis, it starts with the 7.
All right. So it's 7.
And you go up 1 and over 1.
I like it. Up 1 over 1. Or even if I wanted to, down 1 and back 1. So there's my line, right? Now, before I connect the dots, if it was a one-dimensional thing, would I use and I was in Math 90, would I use a closed circle or an open circle? Would I include it or not? Closed. So I want to make a closed line. If it was not equal to, I would make a dotted line that's related to like an open circle, right? So it's equal to, so I make a solid line. I shade my line in. I want to include the points that are on that line. If it could not equal that line, I obviously cannot include the line. It's just on one side or the other. How are we doing so far? Okay. Now how the hell do I figure out which way it's going to go?
Pick a point on either side of the line and plug it in.
I like it. And what do you normally default to if you can? 0, 0. Right? So you pick a test point. You almost always, the only time you can't use 0, 0 is if the line goes through it. You got to pick one side or the other. Now if I plug a 0, 0 in and it works, that means all the answers must be where? Here, right? If I pick this number and it doesn't work, that means all the answers must be up here. So it's very 0, 1. It's very black-white. It says if one side is all answers, the other side is no answers. So if I pick one thing and it works, all the answers must be on that side with it. If it doesn't work, all the answers must be on the other side. How are we doing so far?
Do you want us to shade it paper?
Oh yes. We're not done with this bad boy. So plug a 0, 0 in. Does it work? Is 0 bigger than or equal to 0 plus 7? Is 0 bigger than 7?
No.
So this is not an answer. So all these are not answers. So all these are answers. And of course it goes off forever in each direction, right? So if I pick a point, if I pick that point, whatever that point is, what's true about that point? It won't work if I plug it into this, right? If I pick that point, it will work if I plug it in. Ooh. How we doing? So if I have a problem like this, what do you think your first step is? And a lot of times I get people that do the find the intercepts. That's cool. Unless the intercepts are disgusting, which, you know, right?
What?
Like 11.82 or something. Right? I like that. Just a random thing that made her laugh. So what I almost always do is I solve for y, and then I graph that line. You gonna be okay? Do you need to take a
No,
moment?
she's not. She's insane right now.
Sorry, I'm delirious.
Alright, just right now, okay. I'm making it
No,
worse.
not really.
Alright, so what would you do with this first?
The flush minus.
Good, right, so solve the y, get the minus 2x if you want to. Beautiful, right? And be careful, these are inequalities, so just like always, if you divide or multiply by negative. Good. So y less than or equal to 2 x minus 4. I love it. So go ahead and try to graph that, the solution to that. Still going, right? I know about this line? I know the y-intercept is -4. And then I go up 2 over 5. Technically, I could make those open circles, really, because what kind, no, not open, I meant to make it not equal to, but all 2f. Since it's equal to, I can include the line, so I can make this solid, not dotted, right? Yeah. And again, you can use a test point. 0, 0, and you can put it in the original one, it's a little easier. 0 minus 0, is that bigger than 20? So you don't want to shade in that direction because it didn't work. You want to shade this way. Now, personally, I never use test points. It doesn't mean you can't. All I do is, I want all the y's that are less than the y's that are on this line. So look at this y. Which way would you go if you wanted less than that? Down. Over here. It was greater than, right? Up. The reason that it sometimes gets weird, if you have a really steep slope, it's really hard to tell what's up and down. It looks like left and right now, right? But to me, it's just a quicker way to do it. If you solve for y, you can do it that way. Okay. So you guys try this one here. So real quick, just to solve for y. Cool. So you know the y-intercept is -5. And now here's a little tip. Let me see if I can get you guys. What if the bottom of my paper was right there? Right? Let me not put that on. So I don't have anything else to go. But this says to go down 4 over 3. But it also says to go up 4, back 3. Right? I'm already way down here. Well, I don't want to go further. So I can go up 4, 1, 2, 3, 4, back 3 and be there. Or I can go down 4 over 3. It's the same damn line. Right? Be a little trick to know. What kind of line is it going to be? Good. So not allowed to include the line. The way I represent that is to make a dotted line. Cool. And if you use a test point, is 0 plus 0 bigger than -15?
Yes.
Yes. So that means that this direction must be the answers. To do it the other way, greater than, up. It's getting a little bit slanted, but you can still tell up. Cool. the next level of this, it gets closer to the real world. To do something a little less, a little more abstract here, if I had a series of restrictions, so we only have, let's say, it's got to be, what do I want to say, Jeff? It's got to be more than this, and I can only allow so many people on, and it's got to be positive. I get this little triangle of area that's like my safe area, right? Or my affordable area, or my whatever the restrictions relate to. So this happens a lot in engineering, structural analysis. I mean, how much can we put on this building before it will fall over? And, you know, it kind of tells you the safe zone, really, is a good way to look at it, right? So if you look at this picture, I would need 1, 2, 3 equations or inequalities to kind of build this up, right? So that's the next level, is having more and more inequalities. A system of inequalities, right? It's not nearly as bad as it sounds. So for example, you guys are like, yeah, you always say that. If I had this, all you do is you graph that one all the way. So you don't forget which line is which. So graph the line, figure out which way to shade. On top of that, graph the line, figure out which way to shade. What do you think the answer will then be? Where the two shadings overlap, so they become like a crosshatch. You could do it that way. Some of you guys, this is where some of you guys break out your color pencils, and I love it. As a student, I would never do that. But if you're anal student, anal retentive, you guys know what that word means? Nobody, right? You guys ever watched Saturday Night Live, the anal retentive chef, back in the day when Phil Hartman was still with us? So try that out. Graph both those lines. So graph that line, figure out which way to shade. Graph that line, figure out which way to shade. And then try to make sure you can see where the answer is. Do it. Shouldn't be too evil. Now, obviously, you're not going to start you off there. You just solve for y. It's the same thing. What's the y initial for the first guy? -2, and you go up. 1, 2, 3, 4 over 1. What kind of line will it be? Solid. And I would even do this for you. That's equation number 1, right? I'm not done with it yet. Shade, because if you do both lines, you go back to shade. You're like, okay, which line was which? Oh shit! All right. So get it all the way done. I would just say shade up. This is pretty steep though. Up is kind of weird, but up would be this way. If you put a 0, 0 in, is 0 bigger than 0 minus 2? Yes. So I'm going to shade this way. Some people even just put one arrow that way. It makes it a little less messy. On top of that, this guy is wide except it's 5. You go down 1, 2, 3 over 1. They're not always going to match nice. You don't even care about that really. You just graph them. They just happen to match nice. What kind of line? Dash dotted, whatever you want to call it. Cool. Plug 0, 0 in is 0 less than 5.
Yes.
Yes, and it's down. You can do it either way. So now you do this. Where are your answers then? Kind of like in this here, this blah, 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 blah. This is your answer. However you want to show me. Kind of make sure that I can tell what your answers are. Do better than I just did, is what I'm trying to say. Yeah?
Do you want all 3 of them to be shaded or just the area that's at the arm?
Yeah, that's what I was trying to say. If you don't like all this mess, you can, I'm just going to do it real quick, roughly. So some people put an arrow and then put an arrow, and then they can go, oh, it's in here, right? Even this would be truly enough. This is what you would do in other courses doing this kind of safe zone analysis. You would just kind of, now this tells everybody it's in this shape here, right? If I brought one more equation in that maybe would be like this, you get this triangle area, right? So you could have more than 2 equations. You just keep going. On top of this mess, you throw another one. On top of that mess, you throw another one, right? That's not too bad, right? Pretty simple. Graph a line, plug a number in, shade one way or the other. Do another problem on top of that one. See, even when they throw 2 at you, it's not that big of a deal. That's what I hope. Okay. So the first 2 sections of 5 should definitely be big time review. The thing people normally hate the most is the definitions, which I understand because I actually sort of don't like them either. But we all have to make sure we talk the same language. Which some of you guys would say, I definitely don't talk your language. But
Sandwich. You talk the same language. Sandwich.
Sandwich, yes. A sandwich is officially a very yummy sandwich. If it's okay, I just say it's a sandwich.
Is there going to be definitions on the past one?
Yes, especially these, right? These ones, like identity and contradiction, I'm not really that big into those because the most important thing there is to tell me the answer. Here, this is kind of important. Being able to tell me, for example, the type of polynomial we're working with. But before we get there, what the hell is a polynomial? Why do math people have a name for this thing? There is a method to our madness. Where does method to his madness? Where was that used? Where does it come from? Hamlet. Where am I English? Anybody English majors or don't want to confess to it now? Okay. He's got showing up by math. So why do we call certain things polynomials? Can somebody give me an example of a polynomial?
Big U. 3 and x plus 3.
Okay, well, x plus 3. I like it. That's a polynomial. I like it. Give me another one. Now don't say x plus 5. Yay! What about x squared minus x plus 2? That's an example of a polynomial. What about x to the 58th plus 4x to the 40th minus 7? That's a polynomial. So what seems to be the general overriding rule here?
Anything with 1 variable.
Some combination of terms, right?
Yeah.
Where the terms are separated by pluses or minuses. Now the powers are very specifically defined. I haven't written anything up here with a negative power, have I? Because that would be not polynomial. So this is not a polynomial. This is not a polynomial. This is not A polynomial. So freaky ass things are not polynomial. What's the big deal here though is if somebody tells me they're working with a polynomial, I know I can plug whatever the hell I want to in for x. That's one way to look at it. So to make that happen, why are negative powers bad? And these are actually related. What can I not plug in here for x? What can x not be?
0.
0, because that would freak that piece out, right? And here the same thing, because what does x in negative 1 mean? 1 over x, so it can't be 0 again, right? Here, we don't even necessarily know what a fractional power means yet. Some of you guys might remember. They actually refer to radicals, roots. And roots definitely have a lot of problems. So officially, a polynomial is a collection of terms where all the variables are to whole powers. Right? All the variables are to whole number powers. So it could be squared, it could be cubed, it could be 58th power, it could be the 8 billionth power. I don't care. It could be the 0th power. 3. That's got no x's, right? So that's the 0th power on that one. Next to the 0 is 1. That's why it doesn't show up. How are we doing so far? So you can't use negative powers. You can't use fractional powers. That's basically what a polynomial is. So then I'm certain I could use what the domain would be all real numbers. There's no restriction on my domain. So when I'm talking to a fellow math geek and I say I'm having trouble with a polynomial, by just saying that word, I've told them all that shit. Math people are all about concise. You know, tell me quickly what the hell you're doing, because math people have no patience on it. Okay, so that's the basic idea of a polynomial. Anybody tell me a little bit more about this guy? What specifically, anybody know another name more specific for this guy? Binomial, right? It's got 2 terms, right? That's why it's binomial, like bicycle. What about this guy? Trinomial, like tricycle. I like it. The one type I don't have represented up here that we have a specific name for is a monomial. X, or even, I'm going to blow your mind, 11. There's a monomial. Every number is officially a monomial. It's a single-termed polynomial. Cool. How are we doing? Does this all sound familiar? Vaguely? Anything larger than 3 terms, they just said screw it. We'll call it polynomial, meaning many names, many terms. Poly. Okay, so monomial, binomial, trinomial. Where people get a little freaked out is the next definition, which is the degree of a term and the degree of a polynomial. Let's start with the degree of a term. A degree is not the power that I see. The degree is officially the number of variables that I see. So for example, x squared, yes, that is second degree. Because I see how many x's? 2 x's, right? You guys with me? But what about this? What degree would that be? How many variables do you see in that term?
2.
I see 2 x's and I see 3 y's. So how many variables do you see in that term? 5. Like, so this is a 5th degree term. You guys get the idea? I know that there's an x and a y, but there's actually 2 x's and 3 y's, aren't there? If I expanded this, wouldn't it be x, x, y, y, y? Are there 5 then? Right? That's the easiest way to remember the definition of degree. The reason math people have the word degree, we've decided to define this word, is so that if I tell somebody I have an 8th degree polynomial, I know a lot about it. I actually know what it, sort of what it might look like. I know how many turning points there might be, actually, and this is all kind of like in our future, but this is just to show you there's a reason we have this. I know how quickly it rises. If it's an 8th degree, that's going to rise pretty damn quick.